This is my fifth video lesson for Unit 10. In this lesson, we'll be determining if a process is spontaneous or not. Go to page 22 in the class packet. A cold pack is a bag filled with ammonium nitrate and water in separate compartments. When you snap a cold pack, it becomes cold instantly. When snapping a cold pack, you're allowing the ammonium nitrate to mix with water. So once the ammonium nitrate dissolves, is it an endo or exothermic process? Since the cold pack becomes cold when you snap it, it is an endothermic process because the dissolving process is absorbing energy from the environment. Just to review, when you dissolve salt in water, you must break the ionic bonds. Breaking a bond requires energy. It is endothermic. Once the bonds are broken, the ions will form intramolecular forces with the water. Forming these intramolecular forces releases energy, which is exothermic. The energy required to break the ionic bonds is known as lattice energy, and the energy released from forming those intramolecular forces is known as hydration energies. The sum of these two energies is used to calculate the enthalpy of dissolving the salt. If the delta H is positive, that means the dissolving process is endothermic and the solution will feel cold. If the delta H is negative, that means the dissolving process was exothermic and the solution will feel hot. Based on energetics and enthalpy alone, if a salt is soluble, that means the hydration energy is greater than lattice energy. If a salt is insoluble, it means the lattice energy is greater than hydration energy. This is because the strength of the ionic bonds is related to the lattice energy, and the strength of the intramolecular forces is related to the hydration energy. So if the hydration energy is less than the lattice energy, there wouldn't be enough energy to break the ionic bonds in the first place. That is why the salt will be insoluble when lattice energy is greater than hydration energy. If that's the case, why does ammonium nitrate dissolve in water in the cold pack? The lattice energy of ammonium nitrate is stronger than the hydration energy, because in a cold pack, it is endothermic. The delta H is positive. The lattice energy is greater than hydration. Therefore, the reason cannot be about enthalpy, but about entropy. The reason why ammonium nitrate dissolves in water is because entropy increases when you mix things together. So in this lesson, we will discuss which is the dominating factor, entropy or enthalpy. First, take a moment to watch a TED video about a cold pack. Resume this video once you watch it. The link to the TED video will be in the descriptions. Learning target. At the end of the lesson, I will be able to analyze Gibbs free energy equation to determine if a process, chemical or physical, is spontaneous or not. Homework be number 5, which be a Junipod based off this lesson. How do you know if a process will be spontaneous? Here are 4 possible scenarios. Minus means decreasing, plus means increasing. So how do we know which will have a greater effect, enthalpy or entropy? Here's the equation for Gibbs free energy. Delta G is equal to delta H minus T times delta S. Gibbs free energy equation is used to predict if a process is spontaneous or not. If delta G is negative, it means it's spontaneous. If delta G is positive, it means it's not spontaneous. This equation combines the laws of thermodynamics. Delta H stands for the change of enthalpy, T stands for temperature, delta S stands for the change of entropy. Now let's analyze the 4 scenarios. In the first scenario, enthalpy is decreasing, so it's exothermic, and entropy is positive, so it's increasing. So will delta G be positive or negative? If we use the equation, delta G will be negative. Delta H is negative, T, which is in Kelvin, is always positive, and delta S is positive in this scenario, so a negative number minus a negative number will always give you a negative number for delta G. So is this process spontaneous or not? Since delta G is negative, it is spontaneous. Let's look at the next scenario. Delta H is positive, so it's endothermic, and delta S is positive, so entropy is increasing. So is delta G increasing or decreasing? In the equation, the left side of the equation, the delta H is always positive, and the right side of the equation, minus T delta S will be negative. So in order for delta G to be negative, the right side of the equation, the minus T delta S, must be greater than the left side, delta H. So delta G can be negative or positive. It is dependent on temperature. If the temperature is very high, then the right side of the equation will be greater than the left side. If the temperature is very low, then the right side of the equation will be less than the left side. So this process will only be spontaneous under high temperatures. Let's look at the third scenario. Here we have delta H as negative, so it's exothermic, and delta S as negative, which is decreasing in entropy. So delta G, similar to the previous scenario, will be either negative or positive. But this time, if you look at the equation, the left side will be negative and the right side will be positive. So delta G will only be negative when temperature is very low. So this process will be spontaneous at low temperatures. Let's look at the last scenario. When delta H is positive, so it's endothermic, and delta S is negative, so entropy is decreasing. By using the equation, delta G will always be positive. Since enthalpy is positive, the left side equation will always be positive, and since entropy is negative, the right side of the equation will always be positive. So delta G will always be positive, and it will be never spontaneous. If you recall, the universal law states that all changes tends towards lower enthalpy and higher entropy. It is describing the first scenario, when delta G is negative and is always spontaneous. Here's a real-life example. Diamond will eventually become graphite because delta G is negative. So delta G would tell us if something is spontaneous if a process is favored thermodynamically, but it will not tell us how fast it would be because that is related to rate, which is kinetics. We will discuss kinetics in the following lesson. So the process to convert diamond to graphite, although spontaneous, takes million to billion years. Learning check number 1. Which condition is necessary for a chemical reaction to occur spontaneously? Pause the video and resume once completed. The answer is choice 3. Delta G must be negative. Try to do questions 1, 2, and 3 on your own. Pause the video and resume once completed. Here are the answers. This concludes the video lesson. Remember to do the Junipod homework.